Okay, Andy, the stage is yours. Linux on Z and Crypto Express cards.
All right, thanks, Wilhelm. All right, good morning, everybody. Today I thought I'd talk a little bit about Linux on Z and crypto cards. And this presentation is going to be more from the standpoint of how you would actually go about enabling the crypto cards for Linux on Z. So with that, let's go ahead and get started. Just a second here. So the agenda is going to be pretty straightforward. We'll go talk a little bit about pervasive encryption, and then we'll talk about how to actually configure the crypto cards to be used for your Linux guest under ZVM. And the presentation today, I'm going to concentrate mostly on how to configure them as accelerators. So that will help you with offloading of like SSL and TLS processing that you do for like data in flight. And at the end here, we'll talk a little bit about how to measure the Crypto Express usage from a Linux and from also the HMC. And then if we have time, we can do a demo. If we don't, I've got screenshots to show you what that would actually look like. And then if at the end, we can do questions and answers. So, you know, pervasive encryption has been around for many years, and there's, you know, several different areas that entails. And when it comes to Linux on Z, there's basically two main parts. There's data in flight, so that's think of that as SSL and TLS type communications. So, you know, secure sign-ons and you know, secure web traffic and stuff like that. And then you have data at rest, which is you know, encompasses encrypting disk drives or file systems for data at rest. And built around that technology, IBM has come out with secure service containers, which takes this to a whole new level. And this not only you know, secures the data in flight and data at rest, but it also gives you the ability to do secure boots. It uses signed images. It encrypts dumps. So it's a whole different level of security. And then built on that technology, IBM's come out with a number of what they call hyperprotect offerings, which take advantage of the secure service container technology. In order to utilize the Crypto Express cards, you also have to have available to you another feature that comes with all of your IBM Z mainframes, CPAC-F feature. It's the CPS Systems for cryptographic functions. And this is a coprocessor that sits alongside your IFLs or general purpose engines. And it's a no charge feature. And it usually comes activated when you get your box. It's automatic. You don't have to do anything to use it. It's automatically virtualized and shared across Delpars. You can, it scales very easily. So as you add IFLs or general purpose engines, you get more CPAC-F features. And what it does is it supports a large number of encryption and decryption features, and it provides very high speed symmetric cryptographic functions. So think of it as encrypting and decrypting data at rest, so data in bulk. And then what we're going to concentrate on today are the Crypto Express cards, which are actually PCIe I/O cards that you know, also provide a lot of different functionality around cryptography. They you know, on a Z15 you can have, you know, up to 30 of these cards on the larger Z15, up to 20 on the smaller Z15. They come in a couple different flavors. There's a 2-port card and a 1-port card. The important thing to remember about these is that when you order these initially, you'll have to order a minimum of 2. Because these cards store cryptographic keys, you want to have redundancy and failover, so that's why you'll have to order 2 of them. After that, you can order, one or more, depending on your needs. These cards are virtualized across LPARs using something known as domains, which are basically, you can think of them as a slice of this cryptographic card that can't be seen by any other LPAR. And you can have, depending on what size your Z15 is, the smaller one you can have up to 40, and the larger one you can have up to 85. The domains you assign to specific LPARs. Now you can have, one domain per LPAR. You can actually have multiple domains within a single LPAR, depending on your needs. The Crypto Express cards can be configured in 3 different ways. We're going to, like I said, we're going to concentrate today when they're configured as an accelerator, which is used mostly to offload high volume SSL and TLS processing. You can also configure them in a couple different, or 2 other ways. You can configure them as a coprocessor, a CCA coprocessor. This allows you to do quite a few different functions, but I always think of it as kind of a hybrid configuration where it will also allow you to offload the SSL and TLS processing, but it also allows you to store master keys and other type of cryptographic keys. And then you can, if you have PKCS 11 requirements for your applications, you can configure it in this mode as well. As far as how many cards you would need for your environment, it depends on several different factors, but you may need more than 2 cards based on performance needs. So if you have high level of cryptography that you have to handle, you may have to have multiple cards. You may have to have multiple cards due to how you have them configured. So for instance, you may have a set of cards configured strictly as accelerators to offload this TLS processing, and you might have another set up to do actual setup as coprocessors that store your master keys or whatever else you want to do with them. You might need multiple cards, for instance, if you have them configured as CCA coprocessors and you have a large number of, say, ZVM guests that you have to dedicate different domains to. The Crypto Express cards act as a hardware security module, and they're the state-of-the-art, they're the best in the industry. So the keys that you store in these modules cannot be stolen or tampered with. In fact, if their cards detect that they're being tampered with, they'll clear the keys. So it's very state-of-the-art. The Crypto Express cards, like I mentioned before, do require that you have the CPAC-F feature enabled on your system, and normally it comes enabled. And I'll show you how to check that here in a minute. If you want to look at this in a picture, if you look at the left here, we have a processor, and then if the CPAC-F features, again, are coprocessors that sit beside your IFLs or general purpose engines. So they're housed in the CPC drawers. The Crypto Express cards are IO cards, so they get plugged into your PCIe drawers. And from a management standpoint, the Crypto Express cards can be managed in a number of different ways. In this picture, it shows them being managed with a trusted key entry workstation, which is a recommended way of doing it if you have, for example, a Linux 1 box. If you have ZOS in your environment, you can also manage them from ZOS. For small testing environments, you could utilize actually Linux utilities to load and manage keys, but it's recommended that you utilize a TKE workstation. It provides a lot more security, more user-friendly, and has a lot more options. From a hardware standpoint, the next several screens here are going to go over how to configure the Crypto Express cards from the HMC and from the support element. And they're not that difficult to configure. So first thing you want to check is if you have the CPAC-F feature enabled on your system. In order to do that, you'd start from the HMC, you'd go into single object operations and get to the support element. From the support element, you would go to system management, the serial number for your CPU, and then system details, and it'd show a screen similar to this. And what you're looking for is down here where it says CPS Systems for crypto functions. If that says installed, then you should be all set to go. That means CPAC-F features have been enabled, and you can go ahead and use your Crypto Express cards. So the next thing you'd want to look for is the actual cards that you have on your system. If staying on the support element, if you look over to the left, you'll see you have selections underneath your processor, and one of them is cryptos. If you click on that tab, it'll bring up all your Crypto Express cards that you have available to you. In this case, I have 2 available to me, and they're both operating, so they're available to be used. And over to the right, it tells you what type they are. In order to manage the crypto cards from the support element, you have a number of tasks that you can use to configure the cards and view different characteristics of them. One of the easy ways to get to this is if you go into Task Index and you just filter on crypt, you'll come up with several different tasks here. And what we'll do is we'll start with the crypto configuration task. And what this allows you to do is configure the Crypto Express cards into what I'd mentioned earlier, the 3 different modes. So you'll see that on my system, in this particular screenshot here, I have 2 Crypto Express cards. One of them's configured as a CCA coprocessor, and the other one's configured as an accelerator. In this example, I'll show you how to configure that CCA coprocessor as an accelerator. When you get new cards installed, normally they come as configured as CCA coprocessors. So in order to make these changes, you have to actually take the cards offline. So what you'll end up doing is you'll go ahead and select the card that you want to work with, and it's the same as configuring any other channel on or off. So you'll go in and you'll configure them offline so they go into standby mode. And after that's done, what you'll see is the cards are now stopped and they're in standby. And at this point, you can go back to the crypto configuration panel and you'll be able to actually make that change. And what you're interested in here is the crypto type configuration here tab. If you press on that, what you'll see is a screen similar to this. And what you're going to do is select accelerator over here, and the zeroize the coprocessor is exactly what it sounds like. It will wipe out any keys that you have on that card. So you want to be very careful that you're actually, you have the right card selected and you know exactly what you're doing. It's going to come up after you have done this. Make sure that double check that you're sure what you're doing. You go ahead and press yes. You'll then see that the card is now in accelerator mode. So you can get out of this screen and back on the configuration panel here. You'll now see that both cards are configured as accelerators. This one, the top card here, is actually still deconfigured, so you'll have to configure it on off again. Same thing as you did before, except this time you're just bringing it online. You'll select the partitions that you want to enable it for. And then what you'll see is when the card is being brought online, it will take a minute or so, but it'll show initializing, and then you'll be able to see that it'll turn green and say operating. So at this point, the card's been configured as an accelerator and is ready to use. So the next thing we need to do is configure it to be used for whichever LPARs you want to grant access to it from. So to do that, what we'll do is we'll go back to our list of crypto tasks here, and we'll select change LPAR crypto controls and select the partition that you want to work with. In this case, I selected AH. And what you'll come up with is a screen that looks similar to this. If these are brand new cards and you've never actually configured anything on any of them before, you'll have to actually add these domains and add the cards that you want to have assigned. In this case, I've got, for this partition, I have 2 domains assigned, and I have 2 cards. So the top part are my domains, which are those slices of the cards that I have access to from this LPAR. And then the lower pane here is telling me that I have 2 cards, 0 and 1, and on both of these cards I have the domains 0 and 2 activated. So once I have that, once I've set that up and configured, I'm going to do a save and change, which is a multifunction button here. What this does is it saves the configuration to your activation profile for the LPAR, and it also changes the running LPAR so that it has access to these resources. And that just gives an explanation of what the different buttons on that screen do. So if I want to go back and verify that my activation profiles are set, I can go back and look at my profiles, and under the crypto tab, you'll see the screen is similar to what I showed you before, so that if I deactivate or activate this partition, it will carry forward on the next activation. After I've configured that particular LPAR, if I wanted to take a look and see what the overall configuration for my crypto cards were, to see what everybody else had access to from an LPAR level, I could go and do a view LPAR crypto configuration. And this gives me an overview of how all the cards are configured for each active LPAR. And this screen shows what type of Crypto Express cards I have, how many I have, and then from the on this top pane here, what this shows me is that in AH and AH2 I have both cards configured, 0 and 1. IT down here, for example, only has 1 card configured. And then on the bottom pane, it shows the domains that I have available to me on each one of those partitions. And what you have to remember here is that the domains cannot be assigned to 2 active LPARs at the same time. So if they are, you're going to get conflicts over here. At this point, we're done setting up those cards from a hardware standpoint. And from a ZVM standpoint, fairly easy to configure the cards to be used for your Linux guests. My system currently, I'm using 7.1, and 7.1 allows me to do dynamic cryptographic hardware changes, which means that if I would have added that card and configured it, ZVM would have picked that up, and I wouldn't have had to do a re-IPL of ZVM. In 6.4, you still have to do an IPL if you make hardware changes for the crypto resources. Within ZVM, there's a couple different ways to configure these. The crypto AP vert control statement allows you to configure them as shared resources, so AP virtualize. So VM is going to virtualize those resources across whichever Linux guests you give access to. And then you can also dedicate them to specific guests, in which case each one of those domains that I referenced earlier, you can dedicate a domain to a specific Linux guest. For running these in accelerator mode, AP vert is fine, and it allows VM to actually dynamically choose which crypto resources to use. So you're going to give it a set of resources to use, and then VM will decide which one of those resources it needs to use. In this case, I gave it 2 crypto cards, so we have 2 cards to use. From a Linux standpoint, when you have it in APvert, what you'll see is Linux sees only 1 card and only 1 domain, even though it may be, you know, utilizing more than that. In this case, it's utilizing 2 cards. And the way I have it configured on my system right now, what would normally happen is those requests would be load balanced across those 2 cards. As far as where you place the statements, there's 2 there's 2 changes you need to make. One's within the system config file, and the other one is the crypto APvert or crypto dedicate statements you need to put in your directory entries. You can put them directly in each individual user directory, or you could use them, you could put them in a common profile. For instance, if you wanted to use them across all your Linux guests. So this is what an example of the system config file would look like. What you see here is similar to what you saw in the hardware configuration. I have a 2-member SSI cluster here. I have 2 cards, AP0 and AP1, with 2 domains each, 0 and 2. And then on my second member, I have the same 2 physical cards. Remember that the crypto cards can be shared across LPARs. The domains cannot, so I have 2 different domains configured here. And these match the ones that I put in the hardware configuration earlier. From a user directory standpoint, fairly simple to configure. I've added this crypto APvert statement here. And again, this could go in the individual user directory, or it could be put in a profile, depending on how you wanted to configure it. From a VM standpoint, you can commands you can use to determine what your cryptographic resources are. So if you do a qcrypto, it's going to come up with one of these 2 responses, and basically the first one here is the adjunct processor instructions are installed. That means that it sees the crypto cards, and you can go ahead and use them. If you want to get more details, you can do a qcrypto domain users, and what this will show is both shared and dedicated resources. In this case, I don't have any dedicated resources at the moment. But what this shows is that my one user ID out there, the AHUB crypt Linux guest, has access to those shared resources. From a Linux standpoint, fairly easy to configure it to be used as an accelerator. I've given you examples for all 3 supported distributions here. Let's start with Ubuntu distribution. And what you're actually doing here is you're going to install a few packages here. The ones marked in yellow are normally the ones that you'll have to install. The other ones here are normally installed with a basic installation. After those packages are installed, you'll have to do a little bit of configuration on the SSL conf file. It's fairly easy to do. You'll add a control statement for the OpenSSL conf definition, and then you'll actually copy in the statements from this other file here, which will give you access to all the other configuration options that allow you to use the cards. Now, if you leave this as default, it'll work perfectly fine, but you can also do other configuration things within this file. You can prioritize which cryptographic ciphers are used or which ones aren't used, and various things like that. So there's a lot of different configuration you can do with this file. But if you leave it just right out of the box, you can get up and running pretty quick. And like I said, this is an example. This is like rel 8.2, and then /SP /15 SP1. So file names or locations might change a little bit, but the concept's the same. It's fairly simple to get set up. The one thing you will have to watch out for is that make sure that the configuration statement only shows up once in the file. So as far as from a Linux standpoint, there's different tools you can use to determine how your crypto cards are being used and if you have access to them. So the first one here is just a VMCP command to do a query virtual crypt, which will return this response. And what you'll notice is that it shows that I have one card, AP001, and this tells me that it's a Crypto Express 6 in accelerator mode, and then I only have one domain. Like I said before, I actually have two cards backing this up, but it's being virtualized, so it'll send requests to each card as it sees fit. You can take a look at the file structure that represents the card here. There's a lot of different information in this directory, but you know, one of the more useful files is the request count. And this will increase obviously each time the card gets used. You can also see this, the number of requests that are being processed from the device driver here. This command at the bottom of the screen here, LSC crypt, shows you similar information. One of the important utilities that you get when you install that additional software that I showed you earlier is the ICA info command, and that shows you what cryptographic algorithms are supported and how they're supported, as far as whether they're supported within hardware or software. So if they're supported within hardware, they're going to get processed with the Crypto Express cards and CPAC-F feature. And what you're looking for here is the RSA ME and RSA CRT here. And if those indicate yes in the hardware column, you should be all set and ready to use the crypto cards. Another important utility that comes with the software is the ICA stats. This shows you statistics on what functions have been used and how they were handled. So whether they got handled in software, hardware. So if they get handled in software, that means that the you know, the IFLs are actually doing the processing. And if they're handled in hardware, it's being done with cryptographic hardware. If you want to look at it from a graphical standpoint, you can go to your HMC and you can use the monitor's dashboard function. And what you would do is just go in and select on details. You would select adapters. You would go down and select your, you know, I've got two cards on here, so I'd select both my cards. And I would do a start history from the drop down menu there. And what you'd come up with is a screen that looks similar to this. And as the crypto cards are being used, you'll see various spikes in usage. And you'll see that it started up two tabs here, which I had two cards. So if I flipped over to the other one, you'd see pretty much an identical spike here based on how I have it configured right now. And actually, we do have time to do the demo. So I know I went through that rather quickly. This was kind of more of a presentation on kind of the steps you needed to actually go ahead and set it up and get it to work. So we'll go ahead and do the actual demo. And the environment is pretty simple here. What I've done is I've set up two Linux guests on my Z14. One of them is just a basic Ubuntu 2004 system. It has Apache configured in it for the web server. The other one is a duplicate of that one. The only difference is that it has access to the CPAC-F and Crypto Express facilities. I'm using a benchmarking tool here, Apache Bench, which is a free tool. And all this does is it allows me to run from my laptop and go against these Apache web servers that I have sitting on these Linux guests. And I get to test out various ciphers, encryption ciphers, and hashing algorithms and various things like that. So it allows me to, load it up, how many number of requests, how many requests get performed at the same time, that kind of stuff. And there's many different ways you can test this. OpenSSL has built-in utilities that you can use to do testing as well. So basically what we'll do is we'll run these against my systems here. And the point here is that I want to show you the difference between what what a benchmark would show when you're not using crypto cards and what one does when you are using crypto cards. And the cipher suite here is not important. It just happened to be one that I picked. Obviously, your results are going to vary depending on which cipher suites you use. What other activity you have going on in your system. Obviously, it's going to change when you actually run production workloads. But I thought it was a good example of what could be done with these cards. So what I'm going to do right now is I'm going to go ahead and switch over to my this AHUB base. This is the Linux guest that doesn't have access to the crypto cards. So what we're going to do is we'll just run a SAR command to kind of show you what my CPU usage is. And we'll go ahead and start that up. I'm going to go ahead and flip over to my desktop now, and I'll go ahead and run this benchmark. And you'll see that it's the exact same statement I had in the presentation. And all this is going to do is it'll run various requests against that server, or that web server that's sitting on that Linux guest. And if I switch back over here, what you'll notice is that my CPU usage is climbing, and this will take about 2 or 3 minutes here. I haven't been monitoring the chat. Wilhelm, are there any questions? We can go ahead and answer questions while we're waiting for this to run here.
There was one question for any LPAR. How and where do you have to define the domains, the crypto domains?
So back on the crypto configuration where I showed you the where it was showing the 2 domains that the 0 and 2, and then the 2 crypto cards. That's where you would do that from a hardware standpoint. And then from a VM standpoint, you give them, whichever LPAR that you're running in, you have to give access to those as well. And we can go back to those if you have additional questions.
Yeah, so if there are additional questions, please post them to the chat. That's time now to.
And this should only take another minute or so. But I just wanted to show that, if you're taking up, 20-some%, or, and this changes based on which algorithms you're using, how busy your system is, and, various other aspects. But this is all processing that your real you know, the real application workload can't utilize. So if this will take a minute or so, but if I go ahead and I flip back over to my Linux user that actually has the Crypto Express cards available to it, and I do the same exact thing, so we'll go ahead and start up SAR here just so we can, and then as soon as and this will take a minute or two here. It was running much faster when I was doing this earlier, so of course it's going to run a little slower while I'm trying to do a demo. But in any case, what you would see, and I'll show you this when we start using the other Linux guest, is you'll see that I'm not utilizing, this is a live version of my monitoring the Crypto Express cards, and see what you'll notice is there's no activity here on either one of these.
There's another question here, Andy, if you mind.
Go ahead.
Do you have any numbers showing how much improvement you see with just having CPAC-F alone without the crypto cards or in gas?
Yes, I did do testing on that, and what I saw was, and it depends on the, you know, on what you're actually doing. So for this particular test, so doing a lot of SSL and TLS type transactions, there was, you know, slightly lower CPU utilization, but it was, you know, it was not that much. So, you know, depending on what your CPU utilization was at the time on a base system, what I saw was maybe a 5 or 10% reduction. And remember that the the CPAC-F facility is geared more towards a different type of encryption. So it's really fast at doing bulk data encryption. So they're kind of, I think of them as kind of two opposites here. As it's defined now, the crypto cards are configured to provide the highest benefit for this particular type of traffic, the SSL TLS traffic. So there was some reduction, but not significantly. And again, it would vary, I would think, on the different cipher suites and stuff you were actually using. But the drastic difference, and as soon as this show gets done here, I'll show you the difference. It's gonna, it'll be substantially different. So you do get some benefit, but again, it's not as dramatic as what you do with the crypto cards themselves. And this will be done here in about 2 minutes, I think. Are there any other questions, Wilhelm?
Just see, there's another one coming up.
Okay.
What type of encryption? Oops. What type of encryption does the CPAC-F feature be more useful in? You said bulk encryption.
Yeah, so it's utilized mostly for data at rest. So you know, if you do for when you're encrypting disks and file systems and stuff like that.
And another question is for Java application, is the use of crypto cards transparent or need some setup on Linux, such a specific library?
I believe there's some setup, but I think it's more on the library level. So it's similar to what I did with the OpenSSL configuration.
In general, for exploiting, from a Linux perspective, exploiting cipher suites, specific cipher suites, you need the support for it, so the libraries.
Yeah.
And therefore, those cipher suites which are supported by the crypto cards, they're accelerating those cipher suites. So basically, that's why we're calling it the crypto acceleration card. And the answer for Java is yes, but if you have a Java application, you do not need to care about in the Java application itself. You need to care about in the JDK, which is coming with your distro or is on the system.
Right, right. So the one test got done here, and so we're going to start this up on the system that actually has the Crypto Express cards enabled. So we'll go ahead and fire that up, and what you should see here is a pretty dramatic, make sure I get to, there we go. So what you'll see is that the usage here as far as CPU isn't going to climb. It won't even climb up to 1%. And again, like I said, it depends on which cipher suite you're using. But it's a drastic difference in both CPU usage and also in the time that the actual test is running. So the other test took several minutes to run, and this will take probably 30 seconds. So not only did you not have the overhead of the CPU usage, which means that your applications can actually use those CPUs to get some real work done, but it also pushed a lot more transactions through in a lot less time. So if you have a, if you have a lot of, or a heavy usage, or do a lot of SSL, TLS type transactions, then setting the cards up this way is a really good way to offload that processing. And again, we barely touched or scratched the surface on what these cards can actually do, because they also, like I said before, are hardware security modules, which can be used to store master keys and do, a myriad of other things. So with that, I think I'm pretty much done with my presentation here. I'll go through here and show you what, basically this is what you saw in the demonstration here, but give you a clearer view here, with a system that did not have Crypto Express cards available to it. It was running fairly high utilization. For a card, or for a system that I had access to those cards, dramatic difference. And as mentioned before, the CPAC-F card, I did see a bit of improvement, but it wasn't, it was 5 or 10% less than what the base system was. It wasn't dramatic. And then you would have seen the spikes, and these aren't very long tests, so but both cards show the same thing. They're pretty well load balanced. So with that, I've given you a nice reference chart here. It's got some good material in here to describe how to set this up. It talks about a lot of different things here. One of the new things here is the ZVM 7.1 CP Planning and Administration Guide, Chapter 5. Bill Bittner brought that to my attention a few days ago. Really good chapter. I recommend everybody read it. It goes over how to, what you have to do with ZVM and how everything works with the crypto cards and stuff. So good. It's a good reference chapter. So with that, I think I'm done with my presentation. If there's any other questions, I'll be happy to answer them. And if you have questions after this, my contact information is on the front slide. And with that, Wilhelm, I'm done with my presentation, and I'll turn it back over to you.
Andy, thank you very much. I don't see any other question right now in the chat. If you have any question right now, you can unmute yourself and ask it through the mic or post it in the chat.
All right, and I stopped sharing on my screen, so you can take control back.
Okay. So thank you very much, Andy.
Yep, absolutely.
Stopping the